All right, today's lesson, not a whole lot to it, and hopefully we'll work our way through these things pretty quickly. Perimeter, you might want to think, is just simply the distance around, and you could get away with that, but specifically here, distance around a polygon. Distance around a polygon. Now, don't lose sight of what a polygon is. Remember, a polygon is a simple, closed curve made up of line segments. So it's got to be simple, not intersect itself. It's got to be closed. From the inside, you can't get out. From the outside, you can't get in. And the whole thing has to be made up of line segments. Technically, then, we would have a perimeter. A couple of easy shapes. We've got a rectangle there. If you call one side the length and the other side the width, as you tried to determine all the way around, and so you're going to have the length, right? You don't need to mark anything, just watch, plus the width, then plus what's this side again, the length, right? And plus this side again, the width. So how would you find the perimeter? Length plus width plus length plus width. If we want to add like terms, we could then come up with this formula, right? 2L plus 2W. But basically all it is add up all four sides, right? Just going to add up the length of all four sides. If you talk about a square, well, every side is the same, right? So if the bottom is S, the right-hand side is S, and the top is S, and the left is S. So what would the perimeter be? 4S, 4 times the length of the side. For example, if you had a square that was 3 inches long on each side, the perimeter would be, you have a square, it's 3 inches long on each side, the perimeter would be 4 times 3 is 12, right? If you had a square that's 10 inches long on each side, the perimeter would be 40, because 4 times 10 is 40, right? Because they're all the same, we can just simply shortcut. That's all that formula is, right? A shortcut 4 times S. If you have a parallelogram, as we do here, the bottom is A, the length of it, so we don't know, it's a variable. So if the length of the bottom is A, what's the length of the top? A. And if the length on the right-hand side is B, then the length on the left-hand side is B. And by the way, don't forget, a parallelogram is a quadrilateral, 4-sided figure with both pairs of opposite parallel sides, parallelogram. All right, so this is really similar to the rectangle, isn't it, if you want to figure out the perimeter. Only in this case, you're going to add the 2 A's plus 2 B's. So 2A plus 2B. And again, if you just had numbers, you just count around and add them up. Pretty simplistic, not a whole lot there, not a big deal. But you got to understand that the perimeter is the distance around a polygon. And so if I say to you, find the perimeter, you have to know what the word perimeter means. You definitely don't want to find the area. Is perimeter and area the same thing? And the answer is no. You don't want to find the volume. Volume and area is not the same thing either. So again, you got to know the terminology. So in fact, you are finding the perimeter. All right, so then that leads us to problems like this. Pretty simplistic B. Find the perimeter of a parallelogram if 2 of the sides are 3 inches and 9 inches. Now the key is they told you it was a parallelogram. If you know the formula, there's no need to even draw a picture. If you want to feel safe, go ahead and draw a picture. But what's the formula? 2 times the length of one side plus 2 times the length of the other side, right? How do I know that they didn't give me both of the parallel sides? Because they gave me 2 different values, okay? So 2 times, we'll do the 3 inches first. I always like to include my units so I don't forget them. Plus 2 times 9 inches. Right, we substitute in for the variables. We've been doing this all throughout our pre-algebra. So now we end up with 6 inches plus 18 inches for a whopping grand total of, say, 24 inches. I'm just trying, I know you can add 6 and 18. I just want you to think is what I want. Remember, you got to be thinking, not just copying. And so think it through, right? Twice the one side plus twice the other side. Now again, if you have no earthly idea what to do when you see that and you don't remember the formula, draw the shape yourself. Draw a parallelogram. It's not the prettiest parallelogram, but it'll do. All right, the 3 is smaller than the 9, so I would stick the 3 there. And I would stick the 3 there, right? Because I know it's a parallelogram. I would stick the 9 there, and I would stick the 9 there, and just count up the distance around it, right? Look, if you can't remember the formula, don't miss the problem because it's not that hard, right, Christina?
Right.
Do you know what you were saying right to?
Yes.
You positive? Because you were staring off into, maybe not outer space, but definitely space. All right. Thinking about your lunch? No. Was it good?
Yeah.
Really? What'd you have? Oh, it was good. No matter what it is, if it's pizza, it's always good. I even like bad pizza. I do. I really like good pizza, but I even like bad pizza. All right. You know that there are varying degrees. All right, this kind of problem is definitely the kind of problem you have to know how to solve. Here's the thing, if you look at it on the surface, you'll find that there are 2 values missing. You can put a circle there. We don't have that value, and we don't have that value, and therefore we're not ready to find the perimeter. So the key to a problem like this is being able to find that bottom value and being able to find that left-hand side value. Well, right-hand side on the top. So I want you to look at it, and I want you to figure out what this value is. And I want you to figure out what that value is. Now you can figure these out by looking at the problem. All right, so on 3, give me your value in the bottom circle. On 3, I want everybody saying something. All right, here we go. 1, 2, 3.
8.
All right, and I heard a lot of 8s. Because the point is, if you didn't catch it, according to the top of the shape, watch, from here to here has to be this same distance of 2. And from here to here has to be this same distance of 6. Therefore, the bottom has got to be 8, right? All right, and then on the top circle, on 3, give me an answer. 1, 2, 3.
2.
It has to be 2. We know it has to be 2 for this reason on this one. We know the whole distance is 4. So from here all the way to here is a 4, but we also know this bottom part is 2, therefore the top must have been 2. All right, you got to get that right if you're going to get the problem correct. All right, now the perimeter is just a matter of adding them all up. If you guys are doing homework, please just show me the numbers one time, and then you can use your calculator to add them. Now, it doesn't matter where you start, but be orderly. Start at some side and then continue around in an orderly fashion. I don't care if you go clockwise. I don't care if you go counterclockwise. I don't care where you start. But start at a number and continue around in an orderly fashion. So if I go clockwise, starting at the top is a 2. Then you go on that left side that we found the 2. Then that top part on the right is a 6. Then the right-hand side is a 2. Then the whole bottom is an 8. Then the left-hand side is 4, and them all the way around, right? And then we're just going to add them up. 4, 10, 20, 24. And what do you write if we don't know what the units are? You gotta be careful in these. We're always going to give units. We're just going to use a little u for units because I don't know if those are inches. I don't know if they're feet. I don't know if they're meters. I don't know if they're centimeters. I don't know if they're furlongs. I don't know if they're miles. I don't know. Kilometers. All of that. Emily. A furlong is long. How long is the Chinaman? That's what I want to know. Yeah. Oh, how true. But that's not the case. You ask me how long. Ask me how long is a Chinaman.
How long is it? Wait.
Ask me how long is a Chinaman. How long is a Chinaman?
How long is it?
Absolutely. All right.
How long is
So perimeter. So circumference. Circumference. All right. So circumference is the distance not around a polygon, but around a circle. So when you see the word circumference, you have to think the distance around a circle, not the distance around a polygon. There are two circumference formulas. Does anybody know one of them? Can you raise your hand? Give me one of them. Edward?
The radius times 2 times 314.
Okay, and so we usually write it like this. 2 pi r. 2 pi r is a normal way to write that, which is what Edward said. He said the radius, the r, times 2 times 3.14, which is the pi. So you can just make sure you understand that r is the radius. So that's one way of saying the circumference. Anybody know the other circumference formula? Emily?
Isn't the other one like diameter?
It does involve the diameter. So what times the diameter? It is just pi d. That is correct. So the second formula is pi d, where d is the diameter. Now you might ask, well, why are they different? Because of this relationship. What's the relationship between the radius and the diameter? Luke?
Radius is half of the diameter.
Okay, the radius is half the diameter, or the diameter is what the radius?
The radius.
No. The radius is half of the diameter, or the diameter is what, Juliana? 2 times the radius, right? That's the relationship. And notice the left formula has the 2 and the r, and the right formula has the d, right? Because d equals 2r. So look, which formula do you use? Well, it's nice to know both. If they tell you the radius, use the formula with the radius. If they tell you the diameter, use the formula with the diameter. Now, pi is an irrational number. It means it goes on forever, right? And does not repeat itself. One year, a couple college students wrote a book on pi. The whole book was the number pi. It was, I believe, over 100 pages long, and all it was the number. All right, that was a pretty boring book. But the point was they were looking to see if they could find if it actually did, in fact, repeat, and it went that long. And you got to take supercomputers to try to just run them forever to see if it, in fact, somewhere, somehow, some way it does repeat. And as far as we know, it doesn't. And remember, an irrational number cannot be represented as an integer numerator divided by an integer denominator. We can't find an integer on the top to divide by an integer on the bottom to exactly give us the irrational number. All right, so it's 3.1415, etc. You have a pi button on your calculator, and usually you have to hit a second button to find pi, but go ahead and punch it. Punch your pi button, it should give you 3.1 whatever. So find your pi button. However, a lot of the problems in the book, they tell you instead just use 3.14 for pi. So if you use your pi button and the book says use 3.14, you're going to have a little bit different of an answer. Do you understand that? Because, all right, Daniel, who still has pi on their calculator? You're reading it. Amber, read your number. Okay, so it's 3.1415, blah, blah, blah. So if you stop at 3.14, pi is really a little bit bigger, right? 3.1415, all that other stuff. So if you use your pi button, you're going to get a number a little bit bigger. So just follow directions there. All right, a problem like this is very, very simplistic. Find the circumference of a circle if the radius is 6 inches. So I would use the circumference formula that involves the radius. So again, start with your formula every time. It just takes a couple seconds, but it helps your brain build the pathway to remembering that formula. All right, you can do it as I do it up here. Right now, we'll just sub in the numbers. And again, remember, we're using 3.14 for pi. I always like to include my units so I don't forget them. Normally we'll round to one decimal place unless the number ends, correct? So if somebody's got that, raise your hand. Colby, what do you got?
37.7.
And did it end in 2? Or did it? If it ended in 2, let's just end it in 2 then, Colby, and then we'll be exact, all right? So 37.68 inches. All right, and again, if it kept going, we'd round it to one decimal place, but being it ended in 2, if it ends in 3, we'll just then give it an exact, right? So that's a pretty simplistic problem, no problem. You guys have done those before. Another easy problem, find the circumference of a circle if the diameter is 10 feet. Well, I'd use the other formula, right? C equals pi d. C equals pi d. Okay, sub in your numbers and punch it out. You could even do this one in your head. Now, are you including the units in your work? I hope you are, because that's going to help you to remember to include your units in your final answer. And this is what, 31.4 feet? Pretty simplistic. For some reason, this next problem gets students. So I'm going to see if you can do it. Here's the problem. Find the radius of a circle if the circumference is 43.96 meters. Find the radius, all right? I'm going to pause and let you guys try that one. Guys, you're making it way too hard. So, a minute ago, did we not do a problem where we were finding the circumference? Did we not? And where we knew the radius, did we not? And how did we start that problem? With what?
Circumference.
Well, how did we start the problem? With what?
The formula.
The formula. So did you start this with the formula? Well, C equals 2 pi r, right? And what would be the next logical step? Sub in the values that you know. What is the circumference? 43.96 meters. 2 is a 2. And pi is 3.14. And r is our variable. Now, please don't tell me you didn't know what to do from here. Isn't this an equation? And don't we still remember that things added to the variable, you move by adding their opposite to both sides? And things multiplied times the variable, you move by multiplying by the reciprocal? Isn't this multiplied times the variable? Now, if you want, you can simplify it. For you guys, you probably want to multiply that out first. 2 times 3.14 is 6.28. But you didn't even have to do that first if you didn't want to. And now you're just going to divide both sides by 6.28, right? That's all you're going to do. And because you left your units there, you even know that your answer is going to be in meters, right? So you divide 43.96 by 6.28, and the answer is 7 meters, right? How many got that correct? Right? Makes sense now that you see it? So what, hey, don't have brain cramps over something like that. That's a piece of cake. It's an equation. It's an easy equation. Things are multiplied times the variable. We move by multiplying by the reciprocal. All right, I want you to look up at the screen. If instead of simplifying the box, you moved it by dividing both sides, don't write this, just watch, by dividing both sides by 2 times 3.14. That's fine. However, if you don't punch this into your calculator correctly, Omar, you're going to get a wrong answer. So if you don't punch this, so watch the screen, because here's what most of you will punch. You'll punch the top number, you'll hit the division button, you'll punch the 2, you'll hit the multiplication button, then you'll punch the 3.414. That will not work. And that perhaps is why some of you got the problem wrong. That doesn't work. If you want to punch that way, you have to punch the top number, punch the division number, use a parentheses. So you have to punch a left parentheses, then the 2, then the multiplication, then the 3.14, then the right parentheses, and then it'll give you the correct answer. That's one way to punch it. If you want to punch it without the parentheses, put in the top number, hit the division symbol, put in the 2. Watch this though. Hit the division symbol again. You divide every time by the factors on the bottom, then the 3.14, then your calculator will give you the correct answer. So be careful with punching in your calculator. And again, for that reason, it's safer if you guys just do the 2 times 3.14 in the beginning. Then you don't have to worry about punching it in correctly. But you should learn how to do that, and the sooner the better. Okay, number 2. I think you guys know the answer to this. A blank, let me go down to here. A blank is all the points in a plane that are the same distance from a fixed point. That would be the definition of a cycle. It's a cycle. It's a cycle. Sure. All right, so what is this device here to the left? It is a compass. Woohoo.
We don't have that.
Yeah, I know you don't have it because it's interactive. It's actually gonna move here in a minute. All right, so I'm gonna give a little center point. So if I make that the center of the circle, how does a compass work? Well, a compass works in this respect. Need it to be smaller. I'm going to put the point right on the center point, right? Isn't that how you would use your compass? And let me spin it a little so that I can get to the top. All right, so let me put the point right on the point. Okay, and the pen is going to be purple. And I'm going to open it up. Now look, here's how a compass works. A compass works by keeping all the points on the circle the same distance from the center point. That's what your compass does. So when I go to move this thing around, and if I move it the right way, and if my pen will draw, then I'm putting all these, if my pen will, well, I was playing with this today, draw you pen, I'll get a circle, and I'll get all the points that are the same distance from the center point. Right? That's exactly what a compass is doing. It's putting all the points the same distance from the center point. Stop laughing at my compass. Huh? It is a perfect square. All right, we better go on before we start losing it. So really the idea is a compass ensures that all the points of the circle are the same distance from the center point. So that fixed point is the center of the circle. The fixed point is the center. Okay, so some of you are still struggling with the proper notation for a line. 2 points on the line with the proper line symbol. Some of you are still struggling with proper notation of a ray. The end point, the point without the arrow, and then any point in the direction with the proper symbol. Well, if you're going to name a circle, you have to name it properly. And you need first off the circle symbol, which is simply a circle with the dot in the middle. And if my orientation was a little bit better, it would put that dot in the center. And then you have to name the center point of the circle. So circle X. And that's what we have here to the right, right? Circle X. Not a problem. All right, let's make sure we can name all the other parts of a circle. What would you call line segment QN? This red one here at the bottom. What is line segment QN? What is that called? What is line segment QN called? You guys don't know yet? I would think you would have had this. You musical people, you use this word a lot. Line segment QN. Anybody know? So what we're talking about is a line segment with the endpoints. Line segments with the, turn around, Emily. Line segments with the endpoints as points on the circle. Okay, did you fill that in already, Emily? No, because you're not paying attention to what's going on. So what I'm talking about is like line segment QN. So we have a line segment, and one endpoint is a point on the circle, and the other endpoint is a point on the circle. Edward, you have your hand up. Do you know what we call those?
I was going to say outlier, but...
Nope, definitely not an outlier. Go back to box and whisker. Daniel?
Chord.
It is a chord. A chord is a line segment that has its endpoints as 2 points on the circle. Don't do this on your circle, but I'll show you a bunch of chords. That's a chord. That's a chord. That's a chord. Right? That's a chord. So as long as both endpoints of the segment are points on the circle, then it's a chord. So if I were going to write an example, I would do QN with the line segment symbol over top. Line segment QN. Now, with the points illustrated and the lines illustrated, are there any other chords shown besides chord QN? Luke? PT is a chord. PT is definitely a chord. But what do we usually call a chord that goes through the center of the circle, Colby?
A radius.
Not a radius, so it's got to be then not a radii. Good try, though. Juliana? A diameter. All right. It's all right. Can only be right if you try. So it's a diameter, right? Diameter goes all the way. So is a diameter a chord? Yes. Is every chord a diameter? No. But every diameter is a chord. Okay. Is every chord a diameter? No. Is QN a diameter? No. But is every diameter chord? Yes. All right. So a diameter, I did it backwards here. A chord that goes through the center point is called a diameter. That's what you get for just writing without looking. How many drank the Kool-Aid on that one? All right, drinking out the Kool-Aid. Hope it was cherry. All right, so what would you call a line segment from the center point to a point on the circle? Colby.
A radius.
A radius, yes. All right, a radius from the center point out. And guys, for some reason, students forget this next thing on how to say a radius in proper notation. But I have to start with the center point, has to be listed first. Then the second point is the point on the circle. So if I say line segment XR, that's a radius. Line segment XR. Can anybody name another radius on the circle? Christina. Line segment XP is a radius. And the other one is line segment XT. So again, please note, center point is listed first. Center point is listed first. Center point is listed first. Look, so if I told you I had radius BQ, that must be the radius for circle B, because the center point's always listed first. All right, again, orderly. Math is nice and orderly. All right, and remember, we talked about this already. The relationship between the radius and the diameter is the radius is 1/2 the diameter, or the diameter is twice the radius. Right? Radius is half the diameter, or the diameter is twice the radius. All right, and there are various other things you'll work on tonight. That's basically the idea of the lesson. Keep reviewing. Should be reading through your notes once each day. Won't take long. Just got to get terminology down.